Okay, 7th graders. Rational numbers are numbers that are, they're any number that you can write as a fraction. Okay? Where you can write the number, one number over another number. Any number that you can write as a fraction. So any decimal is a rational number, as long as it's a it's a repeating decimal, or it's a decimal that does not go on randomly and doesn't have an end. Can you think of a number that goes on randomly and doesn't have an end? Pi, right. Pi. Yep. So pi 3.141596254, something like that. That number goes on and on and on, and none of the decimals repeat in a pattern. And so that's called an irrational number. You can't write that number as a fraction. Okay? But there are many other numbers that you can write as fractions. Repeating decimals can be written as fractions, for example. All of these decimals. See, 0.6 is a repeating decimal, or sorry, 2/3, 0.6 repeating. That's a repeating decimal. Any of these, -3/5 or negative 0.6, these are all called rational numbers. Okay?
Yeah.
That's what rational numbers mean. Now, there are some other numbers that you need to know about. Integers, for example. Integers. Integers are rational numbers. We talked about integers before, so just to review, integers are all positive and negative whole numbers. Alright? So any positive or negative whole number is an integer. And on your chart that you're copying, it lists some. Like -12/6 can be reduced to -2, so that's an integer. Okay? 5/1 is an integer. Okay? And then there are just the whole numbers, 0 through infinity, and all the positive whole numbers.
Whoa.
Those are all rational numbers. Okay? So again, some irrational numbers. Can you think of any other irrational numbers? We talked about pi. Do you know what the square root of a number is? What does the square root mean? Really? Yeah. Yep. Right. Since 25 is a perfect square, in other words, you get 25 by using 5 times 5. That means 5 squared is how you get 25, and this is the square root. It's the same number squared is called the square root. Okay? So the square root of 9, for example, is 3. Okay? You would write it this way. The square root of 9, 3 and 3. Okay? And there are lots of perfect squares, right?
Yeah, like that, like
4, 9, 25, 36,
36,
49.
49.
Yep. 81, right? But what was the the square root of 27, for example?
What? 9.
It's not a perfect square, is it?
3.9. I'm guessing.
If you use your calculator, Sam, and you use that radical sign, you're going to get a decimal. Oh, I'm sorry.
Oh, it's like that.
So, AJ, is that a repeating decimal? It's just random, isn't it? So the square root of 27 is an irrational number because it's a random, non-repeating, non-terminating decimal. Okay? And there's no pattern to the numbers, is there? Not really. So that's another example of an irrational number, okay? Let's go back to rational numbers now. We're going to talk about substituting in numbers into a fraction form. So that's what this example is about. Let's say that you're starting with this. A minus B over 3B. A minus B over 3B. Okay? And then it says, let's say that A is negative 6 and B is negative 4. So you're going to substitute the numbers in and figure out what the answer is. Now remember, when you're substituting, always put it in parentheses. And here's why. If you put in negative 6 minus negative 4, you have to remember that this is two minuses in a row, and that equals just plus. So negative 6 minus negative 4 becomes negative 6 plus 4, right? Nod your head if you're with me. Right? Good. And then 3 times negative 4. If you don't put this in parentheses, then it just looks like 3 minus 4, right? But this is 3 times b, so you have to make it 3 times negative 4. Then when you simplify it, negative 6 plus 4 is negative 2. 3 times negative 4 is negative 12. And then reduce it. 2 over 6 is really 2 over 12 is really 1 over 6. Negative 1 over negative 6, which is positive 1 over 6. Okay? Does that make sense? So let's go back. You substitute, and then make sure you put it in parentheses. Reduce this fraction, and then make it positive, okay? Let's go to your assignment, page 206. This lesson is a little bit about reviewing fractions. So number 1, 1/2, 2/4, 3/6. And it says find the next 3 fractions equivalent to a half. How do you find an equivalent fraction, Asa?
Multiply 2 numbers
By what?
2.
By 2 or by any of the same number, right?
But I like 2.
So if you multiply both by 2, you get 6 12, right?
That's not the next one. The pattern is you add 1 to the top one and 2 to the bottom one.
Okay, math teacher.
Oh, I see what you mean. Yes. Yep. I was just asking for an equivalent fraction, but yes, to find the pattern, to complete the pattern, we have to find the next equivalent to 1/2, which is, these are multiples of 1/2, aren't they? So 1 times 4 and 2 times 4. Then 1 times 5 and 2 times 5. So 4 eighths, 5 tenths, and so on, right? Yep.
You need to find the next 3.
Yep, so find the next one.
What page are we on?
Write that down. Number 2.
It says 3 or 2.
Yep, so find the next one also. Number 2, 1/2. Negative 1/2. Negative 3/6. What would be the next 3?
Negative 6. 12s.
Wait.
Nope, 207.
Minus 1 spaces. Oh, no, the bottom one's not negative.
Yeah. So what would we get to get this one?
Mr. Earl, you made it now, Mr. Earl. Mr. Matson, the bottom one's negative.
Oh, yes. I see what you mean. There we go.
I was a spelling teacher.
What would we get next?
We get negative 4 eighths. Right?
Well, what can we use? What if we? What?
It would be positive 3 and positive 6.
Not quite. What if we added negative 2 to this?
That's what I was saying.
And minus 4. What do you get?
I don't know. I
Minus 2.
got negative 5 and negative 10. Which equals negative 1/2, which I don't get.
Well, all these are equivalent except for the first one.
Right.
So that's not a pattern.
These are equivalent. Negative 5 over negative 10 is equivalent to 1/2. AJ? Negative 5 over negative 10 is equivalent to 1/2.
Oh yeah, it's negative.
Yep.
And double negative is positive.
And minus 2, minus 4.
7, 14.
Negative 7 over negative.
Yeah, I forgot the negatives cancel each other out.
Right. Hey, quiet please. Get the next one and this one. Asa, are you writing down the answers? Why not? This is your assignment. Number 3. Write 3 fractions equivalent to each fraction. So 1/6 is given. Now in this case, we could just multiply both by the same number.
Show the times 2 thing.
Just once. No, just would be fine.
What?
Okay?
What?
So we're multiplying by 2. Which one? Yep. Just show it once what you're doing to get the equivalent fraction, okay? Now, number 9. Actually, in 9 through 14, you can put those on the same number line, 9 through 14. It says, graph these numbers on the number line. So mark 0 on your number line. And then, let's see, let's go from -1 to +2. Oops, let's do this, -2, -1, +1. Okay? And then it gives you the first one, 1/10. Number 9 is 1/10. Where would 1/10 go? Caleb?
Where would
1/10 go?
Before the 1.
Here? 1/10. That would be like 9/10.
Oh, like 0.
Yeah.
Yeah.
1/10 would go here. So mark that one. Then number 10 is -3/5. Where would that go? If this is -1/2, where would -3/5 go?
a bit before that? Like after it?
Would it be closer to 0?
No, closer to
Closer to 0.
It's like in the middle of -1/2 and -1. Yeah, it is. Well, yeah.
It's 6.1 more than the middle,
Yep.
or less than the middle.
-3/5, -4/5, -5/5, like that.
Yeah.
So mark that one. Again, feel free to copy this down. You're going to need it for your assignment tomorrow. Otherwise, you'll have to do it on your own. 11 is 2.
Is there a side sauce?
12, -3/10. Hear it. Where would you put that?
What?
The next one.
-0.3.
Will you listen?
Yeah, I know where it goes.
Which one?
-0.3.
Okay, -3/10.
No, it goes like there, right there. It goes
Okay.
0.3. I don't know how to say it. It goes like
What's it close to?
Would it be close to -0.5 or 0?
-1/2.
Closer to -0.5,
But
right?
not too close. Don't
Like
put it too close.
1/10, 2/10, 3/10,
Yeah. Like,
4/10.
yeah. Sort of. Yeah, right there.
Okay, good. So this is -3/10.
But it's called 0.3.
Yeah, it's called.
There's
Okay,
no
or
variables.
-0.3, yep.
There's no variable. French dressing.
And then -7/500, Adam. Where would -7/500 go?
Right before the 1, -1.
Good. So this is right here.
Yeah.
And then 2/3. Laura. Yep, where would you put that one? Before the 1. Before the 9/10. Good. Questions on those? Number 15. A over B. Here's where I want you to substitute, and it says that A is -4, B is -6. So when you're doing your assignment, write this at the top of the section. A equals -4, B equals -6. Write that on your paper above this section. And then substitute the numbers. So -4 over -6. And then you have to put equals, and reduce it to what?
-2 over -3.
Okay. What if we divide them both by -2? Isn't it 2 over 3?
Yeah.
Anytime you have two negatives, you have to get rid of them. Okay? You have to reduce it to a positive. So 2 over 3 is the answer on that one. Asa, turn around. Number 16. I can't believe that you're getting all these answers down. All right. Face forward. Number 16. A plus 9 over B. So then write -4 plus 9 over -6. And then simplify that. Johnny? Yep. 5 over -6. Is that, where could we put the negative sign on this one? Yep, we could put it anywhere. We could put it in front of the whole thing. We could put it in front of the 5, or we could put it in front of the 6. The whole thing is negative. So it doesn't matter where the negative sign goes, it makes the whole fraction negative. Okay? That's really important for later. This is a negative fraction. It's not just a negative denominator, it's a negative fraction. Okay? All right, your assignment is to finish 1 through 20. Let's see, do 1 through 21.
She already did
Okay.
1 and 3.
Yep. We did a lot of these. All of them. 1 through 21.
We've already done like half of them.